This project is the gesture controlled car. My colleagues and I chose this project because we believe that using this gesture controlled car might be a nice step forward into empowering disabled people for future use in the using gesture controlled wheelchairs. So in this project, we used three main modules: the ultrasonic sensor, the H-bridge, and the Bluetooth module, which will be discussed by myself and my colleagues in the upcoming few minutes. Firstly, the gesture control car uses an app from the Android store, which with an accelerometer or a portion of a button sends a corresponding character serially to the Arduino. Now, the app sends an F to move forward, an S to stop, a B to go backwards, an L for left, and R for right. The Bluetooth module has multiple inputs. It has VCC, ground, transmit and receive serially, because we're using the HC05, which has a master-slave property. We wired the module using the VCC of the Arduino board, the ground of the Arduino board, and the transmit of the module to the receive of the Arduino, and vice versa. Then we connected this module using our phone via Bluetooth. The module receives the character from the app, which is then translated to the Arduino board serially, as previously discussed, which is then used in our code to move the H-bridge and the ultrasonic sensor. Now, the H-bridge and the ultrasonic sensor will be discussed further by my colleagues.
Our RC car uses two DC motors to operate. We have one connected to each of the wheels, basically. And controlling and operating DC motors is quite simple, actually. You just supply it with current in one direction and the motor spins. If you reverse the direction of the current, you reverse the direction of spin of the motors. So how do we control these two motors? We actually use an H-bridge motor driver, which allows us to control each of these two wheels separately. The H-bridge provides us with multiple important functionalities. First off, it allows us to control a much higher voltage, namely the one used to drive the two motors, using lower control signal voltages. It also allows us to output current in two different directions, depending on the select bits provided to the H-bridge. And it even allows us to completely enable or disable a motor. So using these functions combined, we can see how we would be able to drive our car in 4 different directions, which are forward, backward, right and left, and also to stop it completely. So luckily for us, it's fairly simple to control all these different directions of motions and even to stop the car. If we need to move the car forward, we just supply the select bits of both motors to spin the motors in the forward direction while enabling both motors. If we need to go in the backwards direction, we reverse the select bits and still enable both motors so they both spin backwards and the car moves in the reverse direction. To move left, you need to drive the right motor forward while disabling the left motor so the car rotates left. And the opposite for the right, you just drive the left motor while disabling the right motor so the car can rotate to the right side.
So in our project, we use the HCSR04 ultrasonic sensor. We use the sensor to be able to detect if there are any objects in front of our RC car. The sensor has 4 pins: the VCC pin, which is connected to the 5-volt output from the Arduino, the ground pin, which is connected to the ground, and the trigger and echo pins are connected to pins 7 and 6 on the Arduino. For the sensor to be able to work, we supply the trigger pin with a high for 10 microseconds. This will send out an 8-cycle sonic burst, and then the time and then the other speaker receives the signal back when it bounces off something, and the echo ping returns the time it took for the sonic burst to travel and be received again. And we calculate the distance by multiplying our time with the speed of sound, which is 340 meters per second. But we divide the time, but we divide the distance by 2, since this is the time it took the sound wave to travel back and forth. We then set the distance to 20 meters on our program, so that it breaks the movement of the RC car. And basically, this is how it works.